Here is the next example. In this example, he gave us the characteristic polynomial equation of a system. Okay, so basically that gives us the number of poles or denominator of a transfer function. This is nothing but a denominator of a transfer function. Now in this question he's asking about find the range of k to be have a stable system. Okay, all we know to have a stable system, as long as the elements in this row are in positive, then we're good, we will have a stable system. So that's what we're going to find. So to find this term here, a equal to multiply these two minus these two divided by this element. So a equal to 35 times 10 minus 50 plus k over 10. Okay, that value is nothing but 350 minus 50 plus k over 10, that is 300 minus k. Okay, 300 minus k over 10. So a equal to 300 minus k over 10. So this value is 300 minus k over 10. Now to find the next element, okay, we'll keep these two elements same. I'm going to take these two, so if you don't have anything, 0. So multiply these two. So 24 minus 2k times 10 minus 0 times 1, which is 0, divided by 10. So we'll end up with 24 minus 2k. Okay, so we're done with that. Now we'll find s to the power of 1. Okay, to find s to the power of 1, since you don't have any elements, we can take that as 0. So these two multiplied minus these two multiplied divided by this. So s to the power of 1 equal to 300 minus k over 10 times 50 plus k minus 10 times 24 minus 2k divided by 300 minus k over 10. We don't have any next element. The next element is going to be 0 because you're going to use these two and these two, so those elements. So here, since I have in this column 0 element, so this the second element here, s to the power of 1 equal to 0. Now s to the power of 0. So to find s to the power of 0, we're going to use these two elements. Okay, everything, this is all together one element, so we're going to use these two elements and this element and 0. Okay, these two elements. So basically these two multiplied minus these two, so we will end up with 300 minus k divided by 10, which is multiplied with 0, so we will end up with 0. So when I multiply these two and divided by this, we will end up with 24 minus 2k. Okay, so in this case we need to have everything positive. So basically 300 minus k over 10 must be greater than 0. So 300 minus k must be greater than 0. So 300 must be greater than k. That's one condition. Another condition is 24 minus 2k must be greater than 0. So 24 must be greater than 2k, and 24 divided by 2, which is 12. 12 must be greater than k. So I end up with 2, but at the same time it must be satisfy this big equation too. So what do I have? The big equation, the big equation here I have 300 minus k over 10 times 50 plus k minus 240 plus 20k over 300 minus k over 10. This must be greater than 0. Okay, I'm going to redo, so I can take this denominator to the other side, make it as 0. So we'll end up with 300 minus k multiplied with 50 plus k minus, so this is over 10, 240 plus 20k must be greater than 0. I'm going to do the calculations. So here what I did the LCM, and so 10 multiplied by 200 and 240, so that's 2400 plus 200k. This whole thing must be greater than 0. So I can take the 10 to the other side and make it equal to 0. So the multiplication, so when I multiply this, 300 times 50, 6,000 minus 50k plus 300k minus k square minus 2400 plus 200k must be greater than 0. So I have minus 50 plus 300 plus 200, so minus k square plus 450k plus 3600 must be greater than 0. Looks like I made a mistake here. I can clearly see, I don't know why I wrote 6000 there. 300 times 50, which is 15,000, right? Now 15,000 minus 2,400, it must be 13,600. Sorry about that error, it must be 13,600. Again, another calculation mistake. It's 12,600. Sorry about that. Okay, so minus k square plus 450k plus 12,600 must be greater than 0. Or if I multiply this to the negative, then k square minus 450k minus 12,600 must be less than 0. Now if you find the k value, you will end up with the k. So after solving this, I end up with k values as minus 26.4 and 476.4. So k value, to get that to have the stabilized system, k value must be between these two numbers. Now from the previous case, I already said k value 300 must be greater than k, and at the same time 12 must be greater than k. Okay, so if you look at these two numbers, so here when you look at the upper limit, I have k value must be less than 300, k value must be less than 12, and k value must be less than 476.4. So which one should we choose? So here it says k value must not be greater than 12, so we have to choose that number to satisfy all the three upper limits. So here the k value must be 26.4, must be less than k, must be less than 12. This is the answer. Here is the next example. In this example, here also he's asking about find the range of k to have a stable system. Okay, so here it's s to the power of 4. Write down all the even number cofactors of s to the power of 4. So this is cofactor of s to the power of 4, cofactor of s square, constant. The next row you're going to write cofactors of s cube, which is 20k, and 10, 0. Okay, now we'll find the s square here. So to find this s square, I'm going to use these two elements in this column, these two elements in this column. So 20k times 5, which is 100k, minus 10 times 1, which is 10 divided by 20k. Okay, that's the first one. And the second one is, so 15 times 0, so we're going to use these two elements in this column, these two elements in this column. We'll end up with 15 there. Okay, now to get s to the power of 1, okay, to get s to the power of 1, we're going to use these two elements and these two, so I end up with this, and this is going to be 0. And again, to get s to the power of 0, this element, I'm going to use these two elements and 15 and 0, so we'll end up with 15 there. Okay, now, so to have a stable system, all these elements in this row must be greater than 0. Okay, so the first one, 20k must be greater than 0. That indicates that k must be greater than 0. That's one condition. Another condition, I end up with k must be greater than 0.1 based on the s square, the cofactor of s square there. Now we'll take the third one, this whole element, make it greater than 0. When I find that, I end up with k values as complex numbers. Okay, so basically I end up having a complex roots. So if you have complex roots, then the system is unstable. Okay, because you cannot find the k value here with complex poles. So whenever you find the complex poles for the constant, say that system is unstable, and we don't know how many unstable poles are there here in this case. I'll stop this video here. Thank you.